All right, this problem asks us to solve this triangle. The first thing we're going to notice about this triangle is that it's not a right triangle, so we can't use SOHCAHTOA. We need to use either the law of sines or the law of cosines. We know two sides and the angle in between them. That's going to require us to use the law of cosines, because the law of sines requires a pair of an angle and its opposite side. We need to know both of those in some pair in order to use the law of sines. Here we know angle A, but we don't know side A. We know side B, but we don't know angle B. We know side C, but we don't know angle C. So we can't use the law of sines. We need to use the law of cosines. And which formula we're going to use for the law of cosines is going to be determined by which angle we know. Here we know angle A. So our formula is going to be A squared equals B squared plus C squared minus 2BC times the cosine of angle A. All right, so now let's plug in what we know into that formula. So we're trying to find side A, which is this side here. A squared is equal to B squared, B is 22, plus C squared, that's 24 squared, minus 2 times 22 times 24 times the cosine of 95 degrees. And now notice that on the right side of this equal sign, we don't have any variables anymore. So we can plug this into a calculator, and what we're going to get is that A squared is equal to 1,152.04. And then we take the square root of that, because this is what A squared is. What we want to know is what is A. So A is going to be equal to the square root of this, which is 33.9417. All right, and so our answer rounded to the nearest tenth is 33.9. But I want to leave this entire answer for right now, because we're going to need to use the length of this side to find these other two angles, and I don't like rounding in the middle of a problem. So now that we know this side, we have an angle pair or an angle and side pair that we know. We know angle A and we know side A. So we can use the law of sines now to finish this problem. So we know that let's find angle B. So the sine of angle B divided by its opposite side, 22, is equal to the sine of A, which is 95 degrees, divided by its opposite side, which is 33.9417. Now I'm going to leave that whole number in there so that we don't compound our error by rounding in the middle of a problem. Okay, so now to get B by itself, we first need to multiply both sides by 22 to get rid of this fraction. So we get sine of B is equal to 22 times the sine of 95 degrees divided by 33.9417. And then to get B by itself, we're going to take the inverse sine of both sides. So we get B is equal to the inverse sine of 22 sine of 95 degrees divided by 33.9417. And so we're going to end up with B being equal to 40.2 degrees, or roughly equal to 42.2 degrees. If you just use 30.9 here, you'd get 40.3 degrees, which isn't off by much, but we want to be as accurate as possible. So if B is equal to 40.2 degrees, then now we know two of the angles in this triangle, and we can use the fact that the angles have to add up to 180 degrees to find the other angle. 95 degrees plus 40.2 degrees is 135.2 degrees. Subtract that from 180. We're going to get that C is equal to 44.8 degrees. And now we've got, this is miles 33.9 miles is the length of the side, and the angles are 40.2 degrees and 44.8 degrees.